Today's day 16 of Unit 7, or it's the first day of Unit 7, Part B. So we started with this warm-up. Take a moment to answer those. So most students really just kind of thought about these in their head, didn't really write a whole lot down. So if you're just thinking kind of backwards, reverse order of operations, opposite operation. So I would subtract or divide 14 by 2 in number 1 to get 7, and then subtract 5 to get 2. So 5 is the answer there. Or 2 is the answer there. Try that again. 14 divided by 2 is 7. 7 minus 5 is 2. And we'll talk more about that in a second. Number 2, same thing, taking 10 and I'm reversing the operation in the reverse order. So 10 minus 6 gives me 4. 4 times 4 is 16. And number 3, taking 23 and adding 4 to get 27, and then taking the cube root of that to get 3. So those are my answers and explanation for how I got those. Now, we then went back, and of course, there's a reason that I had you do this warm-up, and it's because it leads into what we're talking about today, which is what are called inverses. So if I wanted to solve number 1 by writing an equation, I would say that x plus 5, and then that quantity is times 2. And then that equals, in this case, 14, but I could just make that equals y. So if I start with that equation and I want to figure out what's called its inverse, basically what that means is I'm going to get that equation solved for x. So I'm going to first divide by 2, and then second subtract 5. So x equals y over 2 minus 5. And if I then interchange the x and the y, because that's what we want to do for inverses, the input becomes the output becomes the input. So y is equal to x over 2 minus 5. That's the equation for the inverse of the original. Okay, so then we did that for each one of these. So then number 2, writing the equation, when I divide by 4, so x over 4, and then plus 6 equals, in this case, 10, but in general equals y. So if I want to solve that for x to get the inverse, I'm going to first subtract 6. And second, take that expression, take both sides times 4. So I'm going to put that quantity in parentheses times 4. So then I'm getting x is equal to, I can distribute the 4y minus 24. And then interchanging the x and the y, I'm getting y is equal to 4x minus 24. So that's the inverse of the original. Number 3, same idea. When I cube it and then subtract 4. So x cubed minus 4 is equal to y. So if I'm finding the inverse, I'm going to add 4. So x cubed equals y plus 4. And then I'm going to take the cubed root. So I'm getting x is equal to the cubed root of y plus 4. Interchanging x and y is equal to the cubed root of x plus 4. And that x plus 4 is underneath the cubed root. Okay, so that's how we started class today. That we talked about how we find inverses. So then, next thing, you're going to need to turn to your new packet on the first page, and we did these together. So let's do the first one. So if I first need to graph the original equation, so y equals 2x plus 4, let me just quickly graph that. So I have enough couple points here, and I'm going to go ahead and graph that. And label, that's f of x. So then I'm supposed to find the inverse. Well, f of x, we talked about that earlier in there. That's just y. So then I'm going to solve for x. So subtract 4 and divide both sides by 2. I'm going to simplify that, clean this left side up. So y over 2 is the same thing as 1/2 y, and negative 4 over 2 is negative 2. Interchange x and y, 1/2 x minus 2 is equal to y. So that's the equation for the inverse. Now, we don't write it that way though. When it's in function notation, you're going to write the inverse in function notation as well. So I'm going to write that as f inverse of x. So whatever the original was, I just put to the -1, f inverse of x equals 1/2 x minus 2. That's the equation for the inverse. So let me plot those points for that line. So -2, slope is 1/2, rising 1, running 2. A couple times I'll do that. Okay, so I have several points here. Now I can go ahead and graph my line. And that is f inverse of x. Okay, so the next thing you need to do, go ahead and pause the video and do the same thing for parts B, C, and D on page 1. You're going to graph the original, you're going to find the equation for the inverse, and then you're going to graph the inverse. So go ahead and do that now. Again, pause the video while you do parts B, C, and D. Okay, so now hopefully you have done that. So here is B. So I plotted the original, so f of x is my original graph, and then in order to solve that I had to multiply by the reciprocal of -2/3, so -3/2. So f inverse of x is -3/2 x, and then I graphed that as well. There's C, same thing, I graphed the original. I'll just label that original since we can't use function notation this time. So notice that this one, the original one was y, so I don't want to write it in function notation because it wasn't written in function notation, so just y equals. So it gets a little bit confusing because the original and the inverse both are just y equals. It's a little bit hard to tell them apart. But I subtracted 2, divided by 1/3, which is the same thing as multiplying by 3, took that 3 and distributed it to the quantity x minus 2 and got 3x minus 6 is equal to y. So if this was the original, then this is the inverse. Okay, so hopefully you have those. Next, I'm going to move on to part D, and we're going to look at that together. So let me first plot y equals x cubed plus 1. Well, that we should already know what it looks like. It's a cubic shifted up 1. So up 1, put the point of inflection, over 1 and up 1, and left 1 and down 1 from that point gives me my cubic graph. Hopefully you remember that. And now I'm going to find its inverse. So subtract 1 and take the cubed root of both sides. So I have the cubed root of interchanging x minus 1 is equal to y. And again, that's already in y equals form. So I'll just put that in the correct order there. So there's my equation. Now, we don't really know what that looks like. So when we don't know what something looks like, we make a table. So let's see some values I can input. Looks like I can put 0 in because when I subtract 1, I get -1. The cube root of -1, that's -1. So 0, -1, let me plot that. Looks like I can put 1 in. 1 minus 1 is 0. The cube root of 0 is 0. So 1, 0. Looks like I can put in 2. 2 minus 1 is 1. The cubed root of 1 is 1. So 2, 1. Right there. And let's just get a couple more. Looks like if I put in 9, 9 minus 1 is 8. The cubed root of 8 is 2. And looks like if I put in -7, that'll give me -8. The cube root of -8 is -2. So -7, -2 right there. Okay, so I have enough points that I can see that if I flip, let's see, so I'm taking this and I'm basically just taking that graph and I'm flipping it, I'm going to get my I'm going to get that cubic on its side. Something like that. Okay, where this was the original and this is its inverse. Okay. So then at the bottom of the page, page 1, it says, what's the line of symmetry? Well, remember from geometry what that means. It's the line where the one graph, we fold over this line of symmetry and we would get the other graph. Or sometimes just a single graph has a line of symmetry where one half of the graph you fold over to get the other half. So same thing here, except for we're folding the one graph over this line of symmetry to get the other. So if you look at all 4 of our graphs, A, B, C, and D, you hopefully will notice that the line of symmetry is right there, okay? And that line, hopefully you realize, is y equals x. So to answer that question, the line of symmetry between a function and its inverse is always the line y equals x. And you can go back and you can see that on every single one of these. So every single one of these, y equals x is, whoops, got a little bit off there, is that line of symmetry. One folds on top of the other. So for every single one of those. So function and its inverse, the line of symmetry between the function and its inverse is y equals x. Okay. Now, lastly in class, we did do number 1 together from the homework. So take a look at page 2, and let's look at number 1. So it's g of x equals negative 4 over negative x plus 3, and then it's minus 1. So I'm supposed to find the inverse. So the first thing I'm going to do is I'm going to make this y, and I'm going to go ahead and add 1. So y plus 1 equals negative 4 over negative x plus 3. So remember my goal. My goal is to solve for x. Well, right now x is stuck in the denominator. I need to get it out. So I'm going to multiply both sides by negative x plus 3. I'm going to go ahead and put that y plus 1 in parentheses so that I can get the x out of the denominator. So that gives me negative x plus 3 times y plus 1 equals negative 4. So a lot of times here students will mistakenly multiply this out. You don't want to do that because remember your goal is to solve for x. If I multiply it out, I'm getting further away from my goal. It's getting more complicated, not less. So instead, I don't want to multiply it out. I want to get rid of this y plus 1 so that x is by itself. So I get rid of it by doing the opposite of what's being done, which is divide. So I'm going to divide by y plus 1. So that leaves me with negative x plus 3 on the left, and that equals negative 4 over y plus 1. So I'm getting close. I'm going to subtract 3. And now I need to get rid of this negative sign. Well, I'm going to multiply everything through by negative 1. So when I'm multiplying the fraction, be careful. I'm only multiplying the numerator because I'm multiplying by negative 1 over positive 1. So I'm getting x is equal to, that negative becomes a positive for the y. Again, the denominator doesn't change because I'm just multiplying by negative 1. And then the negative 3 becomes plus 3. So now I'm just going to interchange my x and y, and actually while I'm at it, I'm going to rename this g inverse of x because that is the y, and that y becomes an x. So now we have the equation for g inverse of x. Okay, so any that you have that are similar to that, that are rational, that's how you'll approach them. Remember back here, you don't want to multiply that out because your goal all along, just keep telling yourself, the goal is to get x by itself. So if I multiply that out, I'm making it more complicated, not less. So there we go. Now we have our inverse. So you're going to do the rest of problems 1 through 10. So you're going to do 2 through 10 on page 2, and you're going to do page 3, problems 21 to 24 for tomorrow.